Good morning, everyone. It's Miss Jardine again. All right, so we're going to move on with solving inequalities by adding and subtracting. So this is going to be really similar to what we did with equations. The only thing you need to be really careful is that your answer has an inequality sign and not an equals. Because remember, an equals means the two expressions are equal to each other. An inequality means one is less than or greater than the other. All right. So the first inequality we're going to solve is y minus 6 is greater than negative 7. So just like we did with equations, the first thing you're going to notice is the minus 6 on the left. So we're going to do the inverse operation, which is adding 6. Your negative 6 and positive 6 are going to cancel. All you have left on the left side is your y is greater than. So now we need to go back and think about our rules for integers. We've got a negative 7 and a positive 6. Remember, different signs find the difference. So the difference between 7 and 6 is 1. And we had more negatives than positives. Put a box around your solution for me. So that should be y is greater than negative 1. All right, so now we're going to graph it. So we're going to put a circle at negative 1. We are going to look at the arrows. So the arrow for greater than is pointing to the right. So we're going to darken our line going to the right. And notice this is only greater than, not greater than or equal to. So that's going to stay an open circle on our graph. Okay. Number 2. B minus 3.8 is less than or equal to 1.7. So again, when I see a subtraction sign, just like we did with equations, we're going to do an inverse operation. So we're going to do plus 3.8 on the left and plus 3.8 on the right. So your negative and positive is going to cancel. Your sign is going to stay the same. So we have a positive 1.7 and a positive 3.8. So we're going to add those two decimals together, drop that decimal straight down. So your solution on this one is B is less than or equal to 5 5/10. So now we're going to find 5 5/10 in our graph. We're going to put a circle at 5 5/10. You're going to check your arrow of your sign. Less than points to the left. So we're going to darken the arrow going to the left, showing that all of those values could be a solution for B. Since it was less than or equal to, we're going to go ahead and close that circle. And that's showing that 5.5 could be a solution for our variable. Number 3, we've got something a little bit different on this one. So 12 5/10 is greater than or equal to D plus 10. So remember in the previous video, I said you always want to make sure that your variable is on the left. So we're going to rewrite this entire inequality. What I'm going to do is I'm going to take this and flip it to the left side of my inequality. And now I'm going to take my 12 5/10 and flip it to the right. But remember, we talked about last week, when you flip your inequality, you have to flip your sign. So instead of reading it 12.5 is greater than or equal to D plus 10, now it's going to be D plus 10 is less than or equal to 12.5. So that's asking what number plus 10 is less than or equal to 12.5. So just like with equations, we're going to do the inverse operation. We have to get that D all by itself on the left side of our inequality. So the opposite of plus 10 is minus 10, so we're going to subtract 10 from both sides of the inequality. Positive 10 and negative 10 cancel. All we've got is D is less than or equal to, and now we've got to subtract our decimals. And that's going to be a positive 2 and 5/10. Put a box around your solution. D is less than or equal to 2 5/10. So now we're going to graph it. Find 2 5/10 on your number line. You're going to put your circle. You're going to close your circle since it's less than or equal to. Now we're going to look at which direction that arrow is pointing. It's pointing to the left. So that's saying that a solution could be -10, -7, 0, 2.5. Any of those numbers to the left of 2.5 or including 2.5 could be a solution for D. Okay, number 4, we've got another extra step here. So this is x plus 3/4 is greater than 1.5. So we know to add and subtract fractions, we first have to have a common denominator. So the first thing I'm going to do is rewrite that entire inequality using my common denominator. So I'm going to say x plus 3/4 is greater than, not 1.5, I'm going to call that 1.5 1 2/4. So I've got to get my x all by itself, which means I have to subtract 3/4 from the left and 3/4 from the right. My positive and negative cancel. Now look at what you've got on the right side, 1 2/4 minus 3/4. So we're going to borrow from that 1. And I'm going to add 4/4. So 1 2/4, I'm going to call that 6/4 so that I can subtract my 3/4. So 6/4 minus 3/4 is 3/4. All right, so we've got our solution. X is greater than 3/4. Go to your number line, put your circle at 3/4. That's going to stay an open circle. And we're going to look at which direction that arrow is pointing. Greater than points to the right. Find the matching arrow on your number line. We're going to darken in all of those values to the right. So that's saying any number greater than 3/4 could be a solution for x. Okay, we've got one more page of notes. -1/2 is greater than z minus 1/4. So we've got a couple things going on here we need to look at carefully before we start solving. First, I noticed that the z is on the right side and we always want the variable on the left. So the first thing I'm going to do is I'm going to flip that z over here to the left. Z minus 1/4 on the left, and I'm going to flip the -1/2 to the right. Remember, when you flip your expressions from the right to the left or the left to the right, you also have to flip your sign. So instead of -1/2 is greater than z minus 1/4, we're going to read that as z minus 1/4 is less than -1/2. So you also notice now we've got different denominators. So I'm going to go ahead and erase my 1/2, and I'm going to call that 2/4, -2/4. All right, so time for inverse operations to isolate that variable. We're going to add 1/4 on the left, which means we have to do the same thing on the right. Negative and positive cancel. We have z is less than. Now we've got to look carefully at our signs. We had a -2/4 and a positive 1/4. So if I'm just looking at my numerators, I've got a -2 and a positive 1. So -2 plus 1 is -1. So that would be -1/4. Put a box around your solution. Z is less than -1/4. Time to graph our inequality. Go to your number line and put your circle at -1/4, just a teeny tiny bit to the left of 0. That's going to stay an open circle. So you're going to graph everything to the left of that. All right, so why in the world are Mrs. Gormel and Miss Jardine teaching you how to solve an inequality? Because they can be used to solve problems. So we're going to take a look at this real problem. A standard school bus can hold 74 passengers. 29 passengers have already boarded. Write and solve an inequality that represents the additional number of passengers that can board the bus. This will be a one-step inequality. So in the problem, it tells you actually which operation you're going to use to write your inequality, the additional number of passengers. And the first thing we're going to do is define our variable. The variable is always defined by the question being asked that represents the additional number of passengers. Let x equal additional number of passengers. That's what we're trying to figure out. All right, so to write the inequality, we're going to take the number of passengers who have already boarded, which is 29. Then we're going to add an unknown number of passengers. And I know that there can be no more than 74 passengers. No more than. Remember that very first day I told you guys last week to keep that first page of notes because that has all of your clue words. No more than 74 passengers. So that means I could have less than 74. I could have exactly 74, but I can't have more than. So our sign is going to be less than or equal to 29 plus x. So we're going to write that down here on the answer line. 29 plus x is less than or equal to 74. Now we're going to come over here and solve that. Subtract 29 from the left. Subtract 29 from the right. So the number of passengers, we can take up to 45 more passengers on the school bus. Last one, and then you're finished with your math e-learning for today. A person can be no taller than 6 2/25 feet to become an astronaut pilot for NASA. So I'm going to highlight that important information. 6 2/25 feet. Right now, your friend is 5 feet 9 inches tall, but he is still growing. Write and solve an inequality that represents how much your friend can grow and still meet the requirement. So remember, you always want to highlight what is being asked. Write and solve an inequality that represents how much your friend can grow and still meet the requirement. Let x equal, I'm going to call that additional inches. How many more inches can my friend grow and still be an astronaut? So now I'm going to look carefully at the information given. The expected height is 6 2/25 feet. The given current height is 5 feet 9 inches. So I've got a decimal and then I've got a number of feet and inches, and I want all that to be the same. So first of all, I'm going to write my 5 feet 9 inches. There's 12 inches in a foot. So over here, 9 out of 12 reduces to 3/4 equals 7/500. So I'm actually going to call that 5 and 7/500 inches plus how many more inches could be less than or equal to, remember they can't be taller than 6 2/25 feet. So our inequality is 5 and 7/500 plus an unknown number of inches could be less than or equal to 6 2/25. So if we solve that over here, plus x is less than or equal to 6 2/25. Subtract on the left. Subtract on the right. Drop your decimal. My friend can only grow a half an inch half a foot. Half a foot. So 6 inches or a half a foot more to be an astronaut. All right, if you guys have questions, make sure to email your teacher or hop on Zoom during office hours. Have a good day. Bye-bye.